Earth is a water planet. Over 75% of the Earth's surface is covered by water. Our oceans provide about 98% of all habitable space on the planet and are the drivers of our weather. Our excessive use of carbon-based fuels has upset the balance in our seas. The amount of biomass, or the amount of marine creatures living in the oceans, far surpasses that of terrestrial life. The oceans are huge, with an average depth of 13,000 feet, and their stable temperature and currents have produced a very hospitable climate here on Earth. A climate that has made this planet a Garden of Eden. With an average temperature of 58 degrees, life has flourished, but that is rapidly changing and will continue to do so as average temperatures rise. Global warming is changing our oceans. My name is Captain Dan Kipnis, and in this presentation I will explain the changes the oceans are undergoing due to an overload of man-made carbon dioxide in the atmosphere that is then absorbed by the oceans. When we look at the oceans, what we normally see is just a flat surface with maybe a few seagulls flying around, breaking waves, and a blue sky filled with clouds. Looking below the waves, we assume that they are as empty as the surface above, but the reality is that the oceans are filled with a huge amount of biomass. Check out these sharks and porpoise working together to corral this school of sardines. Whoa! Didn't expect that. The whale just ate the whole school of sardines. You know, I'd really like to see that again. Let's take another look. Incredible. Check out the bird coming in behind the whale to eat the sardines. There's so much biomass in the oceans that seems like these tunas and birds feeding on a school of sardines. By the way, many seabirds can swim down 40 to 50 feet to feed on bait fish. Anyway, this drama plays out in the oceans all around the world, all the time, day in and day out. When I look at these striped marlin in the Sea of Cortez off Baja, California, and the seals that are with them, I'm amazed by their speed and agility, beauty and grace. We have here in North America as our symbol for nature on land the bald eagle, but here in the water, symbolizing the bald eagle of the seas, the top predator, we have marlin and sailfish, commonly called billfish. What a majestic and inspiring animal they truly are. For about the past 12 years or so, Dr. Eric Prince has been placing pop-up satellite tags in marlin off the west coast of Central and South America. These tags track the movement, both distance and depth, as well as water temperature of the tagged fish. It quickly became apparent that these fish were not swimming deeper than about 150 feet at any given time. Satellite tag studies of billfish in other parts of the world showed these animals diving to depths exceeding 700 meters. Upon further examination, it was found that dissolved oxygen levels, which need to be very high to support most open ocean pelagic species, only existed in the upper levels of waters off Central and South America. This narrow band of habitable water, shown here in red and black, concentrates pelagic game fish and bait in a shallow upper layer that concentrates their numbers and makes them easier to fish. This is the reason these areas are famed for the outstanding angling opportunities presented to recreational anglers. A couple of years ago, Dr. Prince was presented with the opportunity to place satellite tags in marlin from the Azores and Reunion Islands in the Atlantic. He found that most of these fish swam towards the coast, but two headed offshore. They are shown in the yellow circles. Let's take a look at the one that swam north from the Azores. As you can see in the chart that spanned the month and a half the tag was in the fish, the marlin stayed in the top layer of the ocean. As it moved farther north, it began to feed at greater depth, finally dropping down to 500 meters. This prompted scientists to check the dissolved oxygen levels, and not surprisingly, they resembled the levels found in the Pacific. Scientists have placed spaghetti tags, skinny tags with numbers inscribed on the side, in yellowfin tunas for many years, and a great number have been recovered under the hump of West Africa. The tuna have migrated there for the abundant bait that has been trapped in the upper levels of the ocean by the same dissolved oxygen effect that exists in the Pacific. Commercial, industrial, purse seine, and longline fleets from Europe have known about this effect for many years and have concentrated their efforts on yellowfin tuna, albacore, and skipjack tuna in this area. The yellow circles represent catches in tons, with the result that hundreds of millions of pounds have been caught, leading to the severe overfishing of these species and their possible collapse in the Atlantic. To date, ICAT, the Tuna Regulatory Commission in the Atlantic, has taken no action to reverse the trend. Maybe this new data will change that. I want to show you how a purse seine can be so affected under these conditions. Here's how purse seines do it. It's very simple. Purse seines could be over a mile long, with depths up to 300 feet. Purse seiner sets their net around the whole school of fish. The fish can't swim out the bottom because of the low dissolved oxygen levels. They then close the bottom of the net and pull it in. Purse seiners are capable of landing up to 150,000 pounds of fish per set. Additionally, longliners, some having lines between 40 and 60 miles long, set thousands of hooks. They set them at the same thermocline level looking for tuna, but their bycatch consists of shark, billfish, sea mammals, and turtles, as well as seabirds. Zooplankton are microscopic marine animals that resemble shrimp and crabs. They make up 40% of all plankton and provide the first food source for juvenile fish that have just hatched out of their eggs. Their importance to the food chain is indisputable. If there are no zooplankton, there will be no fish. Without zooplankton, all the juvenile fish that hatch out of their eggs would have nothing to eat and would starve to death. The other type of plankton is phytoplankton. Phytoplankton are much like small plants. They perform the important process of photosynthesis by capturing CO2 molecules and stripping the carbon atom off and holding that atom in their body while sending the oxygen atoms back out into the atmosphere. We all know that trees and plants are responsible for replenishing oxygen we breathe, but the truth is that phytoplankton produce over 70% of the Earth's oxygen. Disrupting the balance or killing the plankton would have a severe effect on the mixture of oxygen and CO2 in the air we breathe. It's easy to see the impact of zooplankton loss when we see how small and vulnerable these juvenile game fish are in the early stages of their life. All of the fish in this slide will attain lengths of several meters and could weigh up to 1,500 pounds at maturity. Scientists are tracking large portions of the ocean which used to be rich plankton-producing areas that now appear to be devoid of plankton. The black areas on the map are plankton-free and appear on satellites as deep blue clear water. These areas appear blue because there is no plankton suspended in them to cloud the water. Plankton-rich water on the map appears green, yellow, and red. Scientists theorize that the ocean has warmed. Cold, deep-water upwellings that carry the nutrient-rich cold water to the surface have been blocked from reaching the depth that plankton need to grow. This trend is worldwide and has accelerated, covering much larger areas in recent years. This is one way the Earth stays cool, but it also illustrates how cold water currents get back down towards the equator and transport nutrients to plankton. Warm water currents run across the oceans at the equator and then head toward the poles. Warm water currents are surface currents, and as they cool, they sink. Cold water currents head back to the equator, and as they heat up, they rise towards the surface, bringing along with them nutrients that the plankton need to reproduce. As the surface of the ocean heats up due to hotter atmospheric temperatures, cooler life-giving water is blocked. This year, recent articles in the magazine The Independent state that global warming is responsible for a 40% loss of the ocean's phytoplankton and that microscopic life critical to the food chain is dying out. As I stated before, the consequences could be catastrophic. And from the publication Nature Geoscience, scientists have found the most devastating impact yet of human-caused global warming, a 40% decline in phytoplankton since 1950, linked to the rise in ocean sea surface temperatures. Boris Worm, a marine biologist, states that we found that temperature had the best power to explain the change, and David Siegel of USC and Brian France of NASA both find a strong correspondence between this chlorophyll record, which is declining, and the changes in both leading climate indices and ocean thermal conditions, which are elevating. The Earth's oceans have heated more than 2 degrees since 1950. Normally, ocean temperature changes take millions of years due to the sheer volume of the oceans. After all, the oceans are huge, covering over 3/4 of the Earth's surface with an average depth of 13,000 feet. Their stable temperature and currents have produced a very hospitable climate here on Earth. Now we have started an oceanic heat-up that will not be able to slow down for many tens of thousands of years. This will continue to affect the climate in negative ways, especially in the formation and strength of tropical storms and rain patterns. Scientists have been able to measure the amount of CO2 in the Earth's atmosphere going back 400,000 years by drilling ice samples in Antarctica and looking at the chemical content of the air bubbles that were trapped in the ice core. This provided an accurate count of how many parts of CO2 per million existed in the atmosphere at that time. The green line represents the level of CO2 present in the atmosphere. The black line represents the temperature. As you can see, the two lines match perfectly. With more CO2 in the atmosphere, temperature went up equally, and with less CO2, temperature went down. We have now exceeded 390 parts per million, with scientists predicting we will surpass 680 parts per million by the end of the century. However, the new IPCC United Nations prediction states that without a concerted effort to control CO2 emissions, or with business as usual with no climate action, that's taking no action to curtail fossil fuel use, we can expect CO2 levels of 1,000 parts per million. And at this level, human and animal life would face great challenges. Knowing that it has gotten hotter as more CO2 enters the atmosphere, following past historical trends, if we continue to do what we are doing now, then it should get very hot very fast. One might say, how is it possible to fill up the Earth's giant atmosphere with greenhouse gases? The simple fact is that the livable atmosphere is not really that big. We look at the sky and it looks like it goes on forever. But the livable atmosphere is only about 6 miles thick. Think about it. You need an oxygen bottle to breathe at the top of Mount Everest. Mankind is putting more than 32 billion tons of CO2 into the atmosphere every year, and it takes over 100 years for that gas to disappear. That means we are adding to this amount each and every day and each and every year.